Hello. Now I am going to discuss about the station blackout scenario and how a nuclear power plant works in that scenario. Station blackout scenario in a nuclear power plant refers to the complete loss of offsite power and the on-site emergency power such as diesel generator and the batteries. This is one of the most severe scenario a nuclear power plant can face, and this can lead to loss of cooling of a nuclear reactor core and the spent fuel pools, and potentially resulting a core damage and radioactive release. Let's see how a station blackout scenario occurs, how is a nuclear power plant designed to handle it, and the measures taken to mitigate these consequences. Now we will discuss about the sequence of events while the station blackout scenario. First, the loss of offsite power due to the failure in the grid due to external events such as the natural disasters and grid instabilities, and the failure of the on-site emergency power supply such as the diesel generators fail to start or the fuel is run out, and the battery banks are depleted due to after providing power for longer time. This will lead to the loss of cooling due to the coolant pump stop operating, leading to rise of temperature in the reactor core. Also, the decay heat continuously will produce even after the shutdown of the reactor. If cooling is not restored, the fuel rods will overheated, which will leading to the cladding failure and the potential core meltdown. And the challenges in the containment that the pressure and temperature inside the containment will increase, which is risking the containment failure and the radioactive release. Now we will discuss about the design features to mitigate the station blackout. Nuclear power plants are designed with multiple layer of defense to prevent or mitigate the consequences of station blackout. The first one is redundant and diverse power sources. We are using multiple number of diesel generators as provide the backup power, and using battery banks to provide short-term power for critical systems until the diesel generator starts. Also using alternative power sources in the plant such as gas turbine, hydroelectric backups, and connections from the other independent offsite grids. Next design feature is passive safety systems. Under this passive cooling system, working with the use of natural circulations to remove the decay heat without relying on electrical power or any operator action. Next is gravity driven systems, working as emergency cooling water is stored at an elevation and flowing with the help of gravity when it is needed. As an example, AP1000 reactor design includes passive residual heat removal system and passive containment cooling system. Next feature is to follow the severe accident management guidelines. It describes the procedures to manage beyond design basis accidents such as these station blackouts. The, these actions may include use of portable pumps and generators to restore the cooling, injecting the borated water to the reactor to prevent the criticality, and venting the containment overpressure using filtration to reduce the radioactive release. Next design feature is enhanced containment structure. A robust containment structure helps to withstand in high pressure and temperature. Also using filtered venting systems in the containment helps to release high pressure while minimizing the radioactive release. Now we can look response to station blackout. As an immediate action, we can implement emergency and activate the station accident management guidelines. Also try to restore the off-site and on-site power. And we can try uh, cooling cooling the core using passive core cooling system if available. Also deploy portable pumps and generators to inject cooling water. In this scenario, we need to keep monitor the temperature and pressure in the containment, and when the containment if necessary to prevent the failure. For the long term action, we must restore the power and the cooling systems and stabilize the reactor and the spent fuel pools. When we consider the case studies from past incidents like Fukushima Daiichi scenario in 2011, a tsunami is caused a station blackout by disabling offsite power and flooding the diesel generator, which leads to loss of cooling and led to core meltdowns in the three reactors. In the modern nuclear power plant, using improved flood protection for the emergency power systems and enhanced diversity and redundancy of power sources and strengthen the severe accident management capabilities. In Three Mile Island incident 1979, the partial station blackout contributed to loss of cooling and leads partial core meltdown. So, from the incident implemented, improve the operator training and emergency procedures and enhance the instrumentation and control system. In conclusion, station blackout scenario is severe but rare in nuclear power plant. Modern nuclear power plant are designed with multiple layer of defense including redundancy in the power sources, passive safety systems and severe accident management guidelines to prevent the core damage and and radioactive release. Continuous improvements in the design, regulations, and operator training essential to further enhance the resilience of the nuclear power plant to such scenarios. Thank you.